Okay, so we're starting this stoichiometry, which it just means the math of chemistry, so figuring out how much product can be produced from a certain amount of reactant. With all these problems, it all comes down to writing formulas, predicting products, and balancing the equation. It's those coefficients in the balanced equation that we need to be able to do the BCA tables. So we're going to start with this. This is 2.5 moles of copper 2 iodide mixed with excess lead 2 nitrate. So we're going to go ahead and write the formulas of these two ionic compounds. Copper 2 iodide plus 2 minus 1, so 1 and 2 is mixed with excess lead 2 nitrate. Lead and nitrate plus 2. This is two reactants. They're both ionic, so it's a double replacement. So we're just going to switch the two negative things around. Copper is now going to be bound to the nitrate. Still has its plus 2 charge. And lead was bound to nitrate, but it's been replaced by iodide still, but lead still has its plus 2 charge. And this, when you go to balance it, should be balanced. You have one copper, 2 iodides, 1 lead, 2 nitrates. So it's balanced, and everything is in a 1-to-1 ratio. So now we can start to figure out the answer to our problem. It says 2.5 moles of copper 2 iodide. So before the reaction, we have 2.5 moles of the copper 2 iodide. Obviously, before the reaction, we don't have any products. It tells us that we have excess. We have plenty of lead 2 nitrate. Determine the number of moles of any solid product. Okay? Well, we know that lead iodide is a solid, so that's what we're going to be looking for here. We're going to go from the before the reaction. We're going to see how much we use up and how much we gain to get this final answer here. Well, since we have excess lead nitrate, we know that the copper 2 iodide is our limiting factor, and we're going to use all of it. And now to get to what we're looking for, the lead iodide, how much of it we created, it's a 1-to-1 ratio. So for every single mole of copper 2 iodide, we're going to produce the same number of moles of lead 2 iodide. So 2.5 moles of copper 2 iodide used should have produced 2.5 moles of lead 2 iodide solid.